Yes. So we're going to take a picture.
You're going to have your whole cells on film. Yes. Good morning, everybody.
Good morning, Mr. House.
Today, boys and girls, we're going to give you an opportunity to continue where we left off. Last time we were together, boys and girls, we talked to you a whole lot about how to solve problems, and we gave you an opportunity to work in groups. Raise your hand and share with Ms. Phillips in the class. What do you remember from last week? Yes, ma'am? We programmed our robot and we made a tree. Awesome. What do you remember? Yes, ma'am?
That we made a bridge and programmed our robot to go over the bridge.
We programmed our robot to go over the bridge. Anything else? Yes. We programmed our robot to go around the tree. Well, today, boys and girls, we're going to continue with that thought about programming, but I want you to understand that in programming, it helps us think. And to think, we need to learn how to solve problems. But let's talk about your problems. How do you solve your problems? Just everyday problems. Yes?
You can, so if somebody takes something out of your hands, you could just say, oh, you can have it.
Okay, so you can make a choice. How do you solve problems? Anybody else? Yes, ma'am?
Well, you can, if someone doesn't want, if someone didn't need to, or someone doesn't want to play with you, you could just walk away and find somebody else.
So you found another solution by just maybe avoidance. I saw your hand up.
So me and my sister are fighting over the last piece of cake. We would slice it in half.
Okay, so you would make a decision by sharing. Well, today, boys and girls, we're going to talk to you a little bit about, excuse me, sweetie, about how to solve problems. And that special word of solving problems is a thinking process called computational thinking. Say that.
Computational thinking.
Excellent. Now, my two friends that are way over here, I need you to scoot a little bit over to this side. I really appreciate it so that you can see the screen. Our light captain is going to turn the lights off for us, and we're going to give you a chance to look at a quick little video that will explain a little bit about computational thinking. After that, boys and girls, we're going to discuss what we see, and we're going to apply it to our programming. Let's take a listen to this video. I hope that you enjoy it.
Recess is over, and we didn't even get a turn on the swings. We never have enough time to do all the fun stuff. You're right, Moby. It's a problem. Let's try to solve it. Computational thinking is a way to understand a problem by breaking it down into smaller parts and creating steps to solve it. Computational thinking helps you solve problems in computer programming, but you can use it to solve problems you see every day. How do you start solving a problem? When you find a problem, stop and think about it. Ask yourself, how can you make it better? How can you change something to make it faster? What can you do to make something clearer or easier? How can you make something fairer for everyone? Our problem is that we don't have enough time at recess to do everything we want. No, Moby, we can't make recess longer, though that would be fun. We should think about what causes the problem or what makes it worse. I'll take notes. Let's see. At recess, we spend a lot of time finding stuff to play with, waiting in line for the swings, and looking for friends from other classes so we can play together. Right, Moby. We spend a lot of time doing these things, which means we have less time to play. It looks like our main problem is actually made up of smaller problems. How do you solve a problem? Now that we know what causes our problem, we can brainstorm ways to solve it. You can observe and take notes about the problem to help you come up with ideas. There can be more than one way to solve it.
All right, boys and girls, we're going to stop right there. All right, so let's take a listen. Now, on the next slide, boys and girls, as you can see, our problems today will be here in the form of a question. How can we debug, identify, and fix errors in an algorithm or program that includes sequences and simple loops? Now, that's a big question. So let's start with the first problem. Let's see if we can identify or define some of these words. What does debug mean? Yes, ma'am?
It means to fix.
It means to fix. Can we have our light captain turn on just the second set of lights for us so we can see? That'll be fantastic. Thank you, light captain. All right, so we're trying to identify and fix a problem. What's an algorithm? We had that last week. Let's see who remembers an algorithm. Yes.
It means to follow the beat.
Well, that's if we were in music, I would say similar to following the beat, but you are following something. What are you following when we're talking about an algorithm? Yes.
A repeat of codes.
Right. So it's part of the code. So the code or the algorithm is a set of instructions. And what did they tell us to do?
Repeat.
Sometimes repeat, and we call that a loop. All right, so an algorithm, boys and girls, that's a set of directions, like a recipe. Remember when we had that similar recipe last week when she was trying to make a cake? Remember that? So there's certain steps. Okay, sequences and simple loops is what he was referring to when we were talking about something repeating. So today, boys and girls, we're going to take a look at the problem. We're going to solve problems. We're going to see errors in our patterns or in our recipes or our algorithms. Let's take a look at the next one. The first thing that we need to do, boys and girls, when I have finished identifying that we have a problem, we need to break the problem into smaller pieces. But you have to think about it first. Just like my friend said, when his sister and him were, they wanted to figure out what to do about cake, they decided to think about it. They said we need to share. That's breaking your problem into smaller pieces. The next thing I want you to take a look at, boys and girls, is when you are coding, you're going to look for patterns. So you might see something that says, remember when we were taking that robot to try to go around the tree? We said straight, straight, turn. Straight, straight, turn. That is a repeated loop. All right, say loop.
Loop.
Say loop repeats.
Loop repeat.
Now turn to your neighbor. Tell your neighbor the same thing.
Loop repeat.
Now let's take a look at the patterns on the board. On the board, types of patterns that we see repeated are what? Raise your hand. What do you see that repeats?
Ooh.
Yes.
His eyeballs.
His eyeballs are repeating. What else is repeating? Yes, ma'am?
His arms.
His arms are going up, down, up, down, up, down. What about in the background? What do you see? Yes.
There's a pattern of triangles.
There's a pattern where you see triangles. And do we see another shape that we see? There's another pattern? Yes. Uh-huh. Yes, ma'am.
The diamonds.
The diamonds. Very good. Now, let's go over our definition again. An algorithm, a set of instructions that can be performed with or without a computer. What are some examples of an algorithm? All right, raise your hand. What are some examples of an algorithm? Remember, they can use a computer or not use a computer. Last week we had an example with the video.
Sure. Yeah, without.
All right, anybody remember an example of, like you either wrote an algorithm in your head or you used your little turn cards? Anybody remember?
Oh, yeah.
Okay, so can you give me an example? One example I remember is when she was trying to teach the Moby how to eat
cake.
cake. So, is it, yes?
And at the end where they fixed everything.
Yes, and it was so funny because he was making a lot of mistakes, but that's because her directions were not what?
Clear.
Our directions weren't clear. Very good. All right, boys and girls, let's take a look at the next slide. Here we talk about decompose, which is a big word, debugging, and we have algorithm again. Now here's our activity. What we're going to do, boys and girls, is we're going to practice our computational thinking by using some items that are in our containers. On your tables, boys and girls, you're going to see a container, and this container has lots of objects. You may have some connectors, cardboard, a couple different other fun pieces. And now I'm going to give you a challenge again. You and your partner will work together creating this one object, because thinking, boys and girls, takes practice. And so what I want you to do, you first have to identify the problem. Secondly, think about it. Thirdly, break your problem down into pieces. And then the last thing, you and your partner work together and with some options, testing out your creations, okay?
Yeah.
All right, so at this time, you and a partner may join us at the tables.